Hey everyone, welcome back. Today, we're diving into something really cool, a side of AI that, get this, doesn't even need a teacher. It's called unsupervised learning. We're going to see how machines can basically become digital detectives, digging through massive amounts of data to find patterns all on their own.
All right, so think about this for a second. Usually, when we teach a machine something, we give it examples with right and wrong answers, right? But what if there are no answers? How in the world can a machine learn anything useful if it's just flying blind?
And that, right there, is the heart of unsupervised learning. It's all about working with raw, totally unlabeled data. No cheat sheets, no correct answers in the back of the book. The machine gets this huge pile of information, and the instruction is basically, all right, go figure it out. See what you can find. This is where we have to totally shift how we think about the goal. We're not trying to predict a specific thing. Nope. The whole mission here is to find the hidden structure that's already lying inside the data itself. Think of the AI like a detective at a crime scene with a mountain of unlabeled evidence. It's just looking for clues, for connections, for anything that links it all together. Okay, so how does it actually do that? Well, it really boils down to a few main jobs. Let's kick things off with the first one, which is probably the most common. It's called clustering. The idea here is so simple, but it's incredibly powerful. Just group similar things together. That's it. That's the whole idea behind clustering. The algorithm just looks at all the data and starts sorting it into little piles, putting things that look alike in the same pile. And this is where it gets super practical. Imagine you run a business. You could feed the algorithm all your customer data. No labels, just the raw info on what they buy, when they buy it, and so on. The machine could automatically spit out groups you never even thought of, like, oh, here are your high spenders, and over here are the bargain hunters. For a business, this is a total game changer. You can market to people based on how they actually behave, not just how you think they behave. All right, on to the second big task. Sometimes the goal isn't about sorting things into groups. Sometimes it's just about making really complicated data a lot simpler to understand. The mission here is pretty straightforward. Make complex data simple. The fancy term for this is dimensionality reduction. Basically, it takes data that has a zillion different features or dimensions and boils it all down to just the most important bits. This makes it way easier to actually work with and see what's going on. And look at this example. It's wild. Imagine trying to understand a data set where every single point has 50 different characteristics. 50. There's no way our brains can picture that. But this technique, it can squish all that information down into a simple 2D chart that you can just look at. And suddenly, bam, you can literally see patterns and groups that were totally invisible before. Okay, for our third and final task, the AI is putting its detective hat back on. But this time, it's not looking for groups. It's looking for the odd one out, the weirdo. It's all about spotting anomalies. This is the core of something called outlier detection. The algorithm's first job is to get a feel for the data, to learn what's normal, what the baseline is. Then its only job is to flag anything that looks, well, weird. Anything that strays too far from that normal baseline. It's basically hunting for the exceptions to the rule. A perfect real-world example of this is fraud detection with your credit card. The algorithm is always watching your spending habits, learning what's typical for you. So, if a crazy transaction suddenly pops up, like a $10,000 purchase in a country you've never been to, the system immediately gives it a high anomaly score. And boom, it gets flagged for you to check out. It's super useful. So, let's just do a super quick recap of these three main jobs. You've got clustering, which sorts things into groups. Then you have dimensionality reduction, which makes messy data simple. And finally, outlier detection, which flags the weird stuff. Three totally different tasks, but they all have the same goal: find the hidden structure in the data. I love this quote because it just nails the whole vibe of unsupervised learning. The machine isn't some student just memorizing flashcards. No, it's more like an explorer heading into a totally unknown land and drawing the map as it goes, based on what it actually discovers. And this really gets to the heart of the difference between the two big types of machine learning. With supervised learning, you have a map and you're trying to find the X that marks the spot. You're predicting a known answer. But with unsupervised learning, you don't have a map. You're the one creating the map by looking up at the stars and figuring out the constellations. Look, if you take away just one thing from all this, let it be this. Unsupervised learning is all about finding hidden patterns in data without being told what to look for. It's the AI of pure exploration and discovery. And that leaves us with this massive, kind of exciting question, doesn't it? If a machine can find patterns that we humans have totally missed, just think about it. What other secrets are buried in all the data out there in the world, just waiting for an AI to come along and uncover them? What kind of breakthroughs are we on the verge of?